If you could travel to the farthest reaches of the cosmos past every galaxy, every star, every flicker of light your eyes could ever see, you would eventually reach a wall. Not a wall of matter, but of understanding. A faint, cosmic haze stretching across the sky. The edge of the observable universe. Beyond it, the light simply stops. Not because there's nothing there, but because light itself has run out of time to reach us. Every photograph we've ever taken of the universe, every star, every nebula, every distant galaxy is a portrait drawn in light. But light has a speed limit. It moves fast enough to circle Earth 7 times in a second, yet even that velocity cannot outrun the expansion of space itself. When we look outward, we're not seeing distance, we're seeing time. Each layer of the sky is an earlier chapter in the story of existence. Look far enough, and you reach the beginning, the moment when light first escaped the fog of the newborn universe, 13.8 billion years ago. That's as far as we can ever see. But space has been expanding ever since, stretching those ancient photons across billions of light years. Today, the edge of the observable universe isn't 13.8 billion light years away. It's about 46 billion. Light left those distant regions before Earth even existed, and it's still traveling toward us, carrying whispers from a past we can never revisit. So, when we say observable universe, what we really mean is the sphere of memory, a finite bubble of visibility within an infinite unknown. Everything beyond it lies forever hidden, expanding faster than light can bridge. Those galaxies, if they exist, are beyond communication, beyond physics as we know it. Their light forever trapped behind the universe's accelerating curtain. And yet, the strangest truth is this: there is no edge out there. The universe doesn't end where our vision fades. It simply continues, indifferent to whether we can see it. Our horizon is not a boundary of space, but of perception. Beyond it may lie more galaxies, more universes, or perhaps realities governed by entirely different laws. But for us, it remains the ultimate mystery, the unreachable frontier carved by the speed of light and the flow of time. Astronomers sometimes describe this horizon as a cosmic prison, a limit we can measure but never cross. Even if we could travel at light speed, the expansion of space would still pull that edge away faster than we could ever chase it. The deeper truth is humbling. There are parts of the universe that no observer anywhere will ever see. They are not hidden by distance, but by destiny. So we stand here at the center of our own bubble of light, small, temporary, and surrounded by the unknown. Our telescopes can map billions of galaxies, but they can never reveal what lies beyond the horizon. It is a realm untouched by photons, unseen by eyes, unreachable by any form of inquiry we possess, and yet we still ask. Because to gaze into that invisible frontier is to confront the very shape of existence, to realize that even in the silence, even in the dark beyond sight, something continues, something vast, unseen, and possibly infinite. This is where our vision ends, but not the universe. Light has always been our messenger. Every truth we know about the cosmos, from the birth of stars to the death of galaxies, rides on its back. It crosses time, carrying the history of the universe in a wave so delicate it can be bent by gravity or swallowed by dust. But for all its brilliance, light has one fatal flaw. It's too slow for eternity. When we look to the night sky, we aren't seeing the universe as it is, but as it was. The stars overhead are ghosts, their light having left millions or even billions of years ago. The Andromeda Galaxy, our nearest galactic neighbor, appears as it did when early humans first learned to make fire. The farther we look, the older the light becomes, until eventually we reach the edge of visibility itself, a horizon beyond which even light cannot return. That horizon exists because the universe is not static. It's expanding and has been since the Big Bang. Space itself stretches like an endless fabric, carrying galaxies away from one another. At small scales, gravity wins, binding planets to stars and stars to galaxies. But across vast distances, expansion dominates, and galaxies drift apart faster than their light can travel. In this strange reality, the further something is, the faster it recedes, not because it moves through space, but because space itself is growing between us. This means there are galaxies right now whose light will never reach us. Not tomorrow, not in 1 trillion years. They are already beyond the cosmic event horizon, the point where the expansion of space outpaces light's ability to cross it. To us, they may as well not exist. Their signals stretch into infinity, redshifted into oblivion. Their stories erased not by distance, but by time's relentless flow. It's a humbling irony. The same light that reveals the universe also confines us within it. The speed of light, that sacred cosmic constant, is both the key and the lock. It defines the shape of reality we can observe, but also the cage that keeps us from seeing beyond it. Every photon that reaches us is a survivor, a lucky traveler that escaped the grasp of an ever-expanding cosmos. Physicists call this invisible boundary, the cosmic light horizon, the limit of everything we can ever know. It's not a wall we can touch, but a boundary we can't escape. Beyond it lies the unobservable universe regions of space-time that are as real as our own, but forever sealed away, expanding beyond reach, faster than information can flow. Even if we sent a ship traveling at light speed toward the edge, it would never arrive. The destination would always recede faster than the traveler could chase it. In this way, the universe resembles a paradox, a boundless expanse where every observer sits, trapped at the center of their own shrinking bubble of visibility. To look outward is to look backward in time, and the deeper we gaze, the closer we come to the beginning, until the light fades into static and the sky itself becomes memory. The cosmos we see is not the cosmos that is. It's only the thin shell of reality illuminated by the patience of light. Beyond that shell lies a realm untouched by photons, unseen by any eye, unreachable by any instrument. And yet, it is still part of the same universe, a continuation of the same story, written on pages we'll never read. The universe isn't silent because it's empty. It's silent because light hasn't reached us yet. And maybe it never will. Before there were stars, before galaxies spun their spirals of light, the universe was fire, a dense, searing ocean of particles, radiation, and energy so hot and so uniform that no light could travel through it. Photons scattered endlessly off free electrons, trapped in a fog of creation that stretched across the newborn cosmos. There were no shapes, no shadows, only brilliance without meaning. Then, around 380,000 years after the Big Bang, the universe exhaled. The inferno cooled enough for protons and electrons to bind into atoms, and for the first time, light broke free. Those first photons began to travel, no longer bouncing between particles, but streaming outward in every direction. That moment was the dawn of transparency, the universe's first visible act. And that ancient light is still all around us. We call it the cosmic microwave background, the faint afterglow of creation itself. It's not light you can see with your eyes, but it's everywhere, filling space with a soft whisper only our instruments can hear. Tune a radio between stations, and a fraction of that static is this relic radiation, the echo of the universe's birth, still humming across 13.8 billion years of expansion. To astronomers, the CMB isn't just a relic, it's a map, a frozen snapshot of the infant cosmos, imprinted with the tiniest ripples of density that would later grow into galaxies, stars, and eventually us. Each pixel in that map, each faint variation in temperature, marks the blueprint of all structure we see today. It's the universe remembering its first breath. But the CMB is also a boundary. Beyond it, we cannot see, not because nothing exists there, but because light itself could not yet move freely. The universe before that moment is hidden, locked behind an opaque curtain of plasma. It's a horizon, not of distance, but of time. When we look at the CMB, we are not looking out into space, we are looking back into the first light that ever existed. Beyond it lies a realm that may never be visible, the primordial darkness before photons could speak. The colors of the CMB we see in images, those soft bands of blue and orange, aren't what the eye would perceive. They represent temperature differences of only millionths of a degree. Yet within those slight fluctuations lie the seeds of everything. Every galaxy, every cluster, every living being, all trace their ancestry to those ancient ripples frozen in light. In a sense, the CMB is the universe's oldest photograph, a baby picture of everything that would ever be. And while we've mapped it in exquisite detail down to microkelvin precision, it still conceals as much as it reveals, because what lies beyond that light, before the dawn of transparency, is lost to us. The universe remembers, but we cannot look back far enough to see. So we stare into the afterglow, the pale, ancient light of the beginning, knowing it's both our window and our wall. Everything beyond it remains forever unseen, perhaps unknowable. Yet that silence, that unreachable past, is the foundation of all we are. The cosmic microwave background isn't just the oldest light. It's the farthest mirror, showing us not what lies beyond, but where we began. Before the universe found its rhythm, before gravity had time to sculpt galaxies or stars, something extraordinary happened. An instant of expansion so violent, so absolute, that it defies imagination. It's called cosmic inflation, and it may be the reason anything exists at all. In the first trillionth of a second after the Big Bang, the universe didn't simply grow, it exploded in scale. Space itself expanded faster than light, stretching quantum ripples into vast waves that would become the framework of galaxies billions of years later. This inflationary burst took the cosmos from subatomic size to astronomical scale almost instantly, a transformation so sudden that if the entire history of the universe were compressed into 1 second, inflation would last less than a whisper. Why it happened remains one of the deepest mysteries in physics. Some theorists suggest it was triggered by a surge of energy in a quantum field, a kind of cosmic tension suddenly releasing. Others think it's a natural consequence of space-time itself, bubbling and fluctuating at the smallest scales. Whatever the cause, inflation flattened the universe, smoothed its irregularities, and set the conditions for everything that followed. But here's where the mystery deepens, because inflation might not have stopped. According to many models, it continues even now, in regions far beyond our cosmic horizon. Our entire observable universe, all 46 billion light-years of it, could be just one pocket where inflation ended, forming a stable bubble within an infinite sea of expansion. Beyond our horizon, other bubbles may exist, other universes, each with its own laws of physics, its own histories, its own versions of reality. This is the idea of eternal inflation, a multiverse, not of fiction, but of mathematics. Each bubble spawns others endlessly, like cosmic foam spreading through a dark ocean. Some may vanish instantly, others may evolve into vast, star-filled realms like ours. Between them lies an ever-expanding void, so fast and violent that no light can cross it. These universes are unreachable, forever isolated by the same physics that gave them birth. To imagine this is to confront the limits of comprehension. Everything we know, every atom, every law, every constant, could be local, confined to our cosmic bubble. Beyond it may lie worlds where gravity is stronger, light moves differently, or atoms never form. Our universe might be just one note in an infinite symphony, and we can only hear the one we're part of. In this view, the observable universe isn't the universe at all. It's merely the calm center in an eternal storm, the region where inflation slowed enough for light to exist, for time to flow, for us to ask questions about it. Beyond that, expansion continues, unchecked, a vast, growing elsewhere that even eternity may never reveal. We exist in a pocket of stillness between infinities, an island of order floating in a sea of unreachable realms. Inflation didn't just create our universe. It sealed it off, locking us inside a cosmic bubble where the rules make sense and light can travel freely, for now. Somewhere beyond that edge, reality may still be inflating, birthing new universes, new possibilities, new versions of everything that could ever be, and all we can do is wonder what it looks like from the outside. We think of the universe as endless, an infinite expanse stretching forever in all directions. But what if infinity isn't a straight line, but a loop? What if space doesn't go on forever, but instead curves back on itself, like the surface of a sphere too vast to ever see the bend? This is the strange realm of cosmic topology, the study of the universe's shape on the grandest scales. It asks one of the oldest and most profound questions. If you travel far enough in one direction, do you ever come back to where you started? Do you reach an edge or a loop? Einstein's theory of general relativity tells us that space and time are not flat, but can bend under the influence of mass and energy. Gravity curves space-time around stars and planets, but could that curvature extend to the universe itself? If the cosmos is finite, yet unbounded, then light could, in theory, loop around it. That means the stars we see might not all be distant strangers, but multiple images of the same galaxies seen from different directions and different times. It's a breathtaking thought that the sky could be filled with echoes of ourselves, reflections of reality bent through the geometry of existence. Detecting such loops, however, is nearly impossible. The scale is immense, and the expansion of space stretches light faster than it can return. Still, cosmologists continue to search for subtle hints repeating circles, mirrored temperature patterns, or strange alignments within the cosmic microwave background. These could be the fingerprints of a curved, looping cosmos, a universe whose geometry folds back on itself like a cosmic hall of mirrors. Some models suggest the universe could take the form of a 3 torus, a 3-dimensional version of a donut where every edge connects seamlessly to another. Travel far enough in one direction and you'd reappear from the opposite side, never crossing an edge because there is none. Other possibilities imagine a dodecahedral universe, 12 pentagonal faces, connected so that light leaving one face re-enters through another, rotated by 36 degrees. In such a universe, the sky itself might contain overlapping imprints, faint, repeated constellations hidden among the stars. If these echoes exist, they would redefine how we perceive reality. The night sky could be both infinite and enclosed, showing us multiple images of the same cosmic story, repeated across time and space like reflections in a kaleidoscope. But the deeper truth may be subtler and stranger still. If inflation stretched the early universe far beyond our visible horizon, it could appear flat to us, even if it curves gently over distances too vast to ever measure. Like standing in the middle of an endless plain, we see no bend because the arc is too wide to notice. In that sense, the universe could be both finite and infinite, finite in shape, but without boundary, looping endlessly in every direction. It's the paradox of infinity, not endless distance, but endless connection. The universe may contain everything, including itself. Perhaps, if you traveled long enough, you'd one day return home without ever realizing you'd circled through space-time itself. And maybe that's the ultimate illusion, the idea that beyond even exists. There may be no edge to cross, no border to breach, only the continuous fabric of reality, folding quietly back on itself, whispering that we are already everywhere we could ever go. In trying to find the shape of the infinite, we may discover that the universe has no outside, only within. There's a limit to how far we can see, not because the universe ends there, but because light itself does. That invisible frontier is known as the cosmic horizon, the farthest edge of the observable universe. Beyond it lies a realm we can never reach, a region where the laws of physics may still hold, but where time and light have slipped forever beyond our grasp. It's a humbling truth. The universe may be infinite, but our vision of it is not. The light we see from the farthest galaxies began its journey nearly 14 billion years ago. As it traveled, the cosmos expanded, stretching those wavelengths into redder tones until they faded into the faint background glow of space. Anything farther away, any galaxy whose light hasn't had enough time to reach us, remains hidden beyond that shimmering horizon. To gaze outward is to gaze backward in time. Every photon we catch is ancient, a message written billions of years ago. Beyond that limit, we can only infer, imagine, and calculate. The galaxies out there still exist. They're just receding faster than light, can close the gap. Not because they move through space faster than light, but because space itself expands faster than light can cross. The edge of visibility, then, isn't a boundary of matter, it's the limit of causality itself. So what lies beyond that horizon, beyond the reach of every telescope and every dream? Physics offers whispers. The patterns of the cosmic microwave background suggest that the universe beyond our view looks much like what we see here: clusters, filaments, and voids continuing endlessly into the dark. The same physical laws that shape us likely sculpt those unseen realms as well. But some possibilities are far stranger. There could be regions that cooled at different rates after inflation, forming bubbles of space with slightly altered physical constants, gravity a little stronger, light bending in different ways, atoms bonding differently. In others, matter might never have coalesced at all, no stars, no planets, no observers to wonder about them. These hidden domains, born from the chaos of inflation, might each carry its own version of reality. Though we'll never see them directly, they could still leave faint fingerprints, gravitational nudges, tiny irregularities in the cosmic background, cold spots, or strange alignments that don't quite fit our models. Some cosmologists suspect these may be bruises of contact, ancient collisions between our bubble universe and others, ripples of energy left from where two expanding realities brushed long ago. If true, then our cosmic horizon isn't an end, but a scar. In that sense, the edge of the observable universe is more veil than wall, a horizon of perception, not of existence. Beyond it, the story continues, written in wavelengths too long and timescales too vast for us to ever decode. The cosmos doesn't stop when our sight does. It keeps unfolding, infinitely and indifferently, carrying its secrets beyond the reach of light. Every night, when we look up, we're staring at that boundary, a luminous circle 46 billion light-years wide that defines everything we can ever know. Beyond it lies the rest of reality, unseen, untouched, but inevitable. The edge of sight isn't the edge of the universe. It's simply where the light runs out. And maybe, just maybe, beyond that silence, the echoes of other worlds still hum faintly, waiting for a listener who will never come. Every star, every galaxy, every radiant beam we've ever seen together, they make up less than 5% of the cosmos. The rest is invisible, not empty, but unseen. A vast, shadowed framework of dark matter, the hidden architecture upon which all of existence is built. If light is the paint of the universe, dark matter is the canvas. It neither glows nor absorbs, and it ignores the forces that light obeys. Yet it shapes everything. We know it's there not because we see it, but because of what we can't explain without it. When astronomers map the motion of galaxies, they find stars orbiting far faster than gravity from visible matter could allow. Entire galaxies should fly apart, yet they don't. Something unseen holds them together, an invisible mass binding the cosmos in its silent grip. Whatever it is, it outweighs ordinary matter by nearly 6 to 1. Without it, galaxies wouldn't exist, stars wouldn't cluster, and the universe itself would unravel into chaos. Dark matter forms the skeleton of the cosmos, a web of invisible filaments stretching through space. Long before the first galaxies blazed to life, dark matter clumped together under gravity's pull, forming dense nodes connected by strands that spanned millions of light years. Later, gas and dust fell into those invisible wells, where stars ignited and galaxies took shape. Every spiral, every cluster, every glowing nebula we see today is simply light tracing the structure of shadow. We've searched for dark matter and failed to catch it. Deep underground detectors listen for faint collisions between these mysterious particles and ordinary atoms, quiet flashes that might reveal their presence. Physicists once hoped for WIMPs, weakly interacting massive particles, then turned to more elusive candidates like axions, ghost-like particles that might hum faintly in magnetic fields. Decades of searching have yielded no certain signal. The architects remain invisible, and yet their influence is everywhere. When we observe gravitational lensing light bending around massive galaxy clusters, we're watching the handiwork of dark matter itself. It distorts space, acting as a lens made of gravity, magnifying galaxies that would otherwise be hidden behind others. Through these warped views, astronomers can map the unseen, tracing the contours of an invisible cosmos that cradles all we know. This web, woven from the invisible, connects galaxies like beads on strings, forming the universe's grandest pattern, the cosmic web. And beyond our horizon, that pattern likely continues without end, filaments and nodes, extending into realms we can never touch. If the universe beyond mirrors what we see here, then dark matter's reach is infinite, a lattice stretching across eternity, holding together realities that light will never illuminate. We live within that unseen framework, suspended in a structure we can't perceive directly, guided by forces we still don't understand. Every star that burns, every planet that orbits, every breath we take is balanced upon the tension between light and shadow. To gaze into the night sky is to see only the decoration of something vaster, an invisible cathedral of matter and gravity, built by hands that leave no trace. And though dark matter remains silent, its silence speaks volumes. It reminds us that the universe is not defined by what we see, but by what holds everything together when sight ends. The cosmos may glow with light, but its strength lies in shadow, the hidden architecture that gives shape to existence itself. If dark matter is the skeleton that holds the universe together, then dark energy is the force that's pulling it apart. It is the quietest, most powerful mystery in existence, an invisible pressure stretching the very fabric of space, driving galaxies away from one another faster and faster with every passing moment. The story began unexpectedly. In the late 1990 seconds, two teams of astronomers studying distant Type Ia supernovae cosmic explosions that serve as mile markers for measuring the universe's scale expected to find that cosmic expansion was slowing under gravity's pull. But the data revealed the opposite. The explosions were dimmer than predicted, farther away than they should have been. The universe wasn't slowing, it was accelerating. Something unknown was overpowering gravity on the grandest scales, pushing galaxies apart with relentless energy. Scientists named it dark energy, not because it behaves like matter, but because it's a mystery. It doesn't clump, it doesn't emit light, and it may not even be energy in the traditional sense. It's simply there. A property of space itself, woven into every inch of the cosmos, invisible yet omnipresent. Einstein once proposed something similar, the cosmological constant, a mathematical term he added to his equations to hold the universe in balance. He later called it his greatest blunder, but perhaps he was right all along. Dark energy could be that same constant, a pressure inherent to the vacuum of space, causing expansion to accelerate the more the universe grows. Imagine stretching a rubber sheet that doesn't resist but helps you stretch it the farther it goes, the faster it expands. That's dark energy. The more the universe expands, the more space there is for dark energy to act upon, creating a self-sustaining acceleration. Because of it, galaxies are racing away from each other at increasing speeds. Already, more than 90% of all galaxies lie beyond our cosmic reach. Receding faster than light can bridge the distance. Not because they're moving through space faster than light, but because space itself is expanding faster than light can cross. Each passing second, more of the universe disappears beyond the horizon, its light forever unreachable. If this continues indefinitely, the cosmos faces a slow, inevitable unraveling galaxies drifting into isolation, stars burning out one by one until only cold, empty space remains. Astronomers call it the Big Freeze, a future where expansion never stops, but life and energy fade into silence. And yet, dark energy itself remains almost unknowable. Is it truly constant, or could it change over time, weakening, reversing, or intensifying? Some theories suggest it might one day collapse, ending expansion in a big crunch where gravity reclaims everything in a final cosmic implosion. Others warn of the opposite fate, a big rip, when dark energy's power grows so strong that it tears apart galaxies, atoms, even the fabric of space-time itself. Whatever its nature, dark energy defines our cosmic destiny. It's the invisible conductor of the universe's future, unseen, immeasurable, yet absolute. And perhaps the strangest truth of all is this: the more we learn, the more the universe slips away. Every second, more galaxies vanish beyond our horizon. The night sky we see today, the constellations, the spirals, the faintest galaxies at the edge of our telescopes, is only a fleeting glimpse of a universe already vanishing into darkness. We live in a rare and fragile moment, the brief epoch when light can still reach us, when the universe is still visible, when we can still ask why. Someday, far in the future, no trace of the cosmic web will remain in view. The stars will fade, the horizon will close, and the universe will grow quiet once more. Dark energy ensures that everything we know drifts apart, but it also gives meaning to our moment within it. Because now, before the silence, we can still see the vastness. We can still wonder. And maybe that's enough to know that we exist in the instant, when the universe still lets us look back. If the observable universe is just one bubble of existence, then a haunting question lingers at the edge of everything we know. What lies beyond our own? For decades, cosmologists have speculated that the Big Bang was not a singular beginning, but one of countless cosmic births, each giving rise to its own universe, with its own laws, constants, and dimensions. Together, these form a vast and eternal landscape known as the multiverse. It sounds like fiction, but it emerges naturally from physics. The same theory that explains our universe's earliest moments, cosmic inflation, may also predict the existence of infinitely many others. Inflation describes how, in the first instant after the Big Bang, space expanded exponentially faster than light, smoothing out irregularities and setting the stage for everything that followed. But according to most models, inflation never truly ends. It halts in some regions while continuing in others, creating endless pockets of space-time where new universes can form. That means our entire cosmos, every galaxy, every atom, every thought, could be just one bubble in a vast cosmic foam. Each bubble universe forms from random quantum fluctuations at the edge of inflation's chaos. Some might have stronger gravity or different physical constants. Others might be too unstable for matter to exist at all. And somewhere, perhaps, a universe almost identical to ours could be unfolding its own observers, looking outward, wondering the same thing. In this view, the word universe suddenly feels too small. What we call the cosmos may be just one island in an infinite archipelago of reality, each separated by an ocean of expanding space so violent that no signal can ever cross it. To us, those other universes are as unreachable as dreams, but their existence might still leave traces, faint ripples, cosmic fingerprints pressed into the fabric of our own. Some cosmologists believe that strange features in the cosmic microwave background, cold spots, asymmetries, or unusual alignments might be evidence of collisions between universes long ago. Like raindrops merging on a pond, their boundaries could have brushed against ours, sending shockwaves through the newborn cosmos. If true, our universe carries scars, bruises of contact from realities beyond perception. Then there's the quantum multiverse, born not from inflation, but from probability itself. In quantum mechanics, every event with multiple possible outcomes doesn't choose it, creates them all. Every decision, every particle's decay, every random fluctuation spawns new branches of existence. Somewhere in another universe, you never read these words. In another, you never existed. In another, you look up at a sky where the stars never formed. This idea, called the many worlds interpretation, suggests that reality isn't singular, it's an ever-dividing tree of possibilities, growing endlessly from the roots of uncertainty. The implications are staggering. If the multiverse is real, then the laws of physics we revere might be local temporary rules that apply only to our bubble. Beyond it, nature could rewrite its own script endlessly, exploring every conceivable version of reality. And yet, there's beauty in the thought. Every horizon we reach reveals another beyond it. Every discovery, another mystery. The multiverse doesn't make existence smaller, it makes it infinite. If other universes exist, their light will never touch us. Their time will never sync with ours. But they remind us of something profound, that even within our small, brief corner of space-time, we are part of a grander design, an eternal experiment in possibility. Perhaps, somewhere out there, another version of us is staring into a night sky filled with the same questions and feeling the same awe, because in every universe, curiosity might be the one constant. The multiverse doesn't end the story of existence. It simply makes the story eternal. At the farthest edge of everything we can see lies, not an end, but a mirror. Beyond the cosmic horizon, past the glow of the first light and the silence of the dark, the universe reflects something deeper. Our search for meaning in the infinite. For centuries, we've looked outward to understand where we are charting stars, naming galaxies, measuring time in the echoes of creation. But the more we uncover, the clearer it becomes that the cosmos is not just a place we inhabit. It's a story we are woven into. The same laws that shape galaxies shape our thoughts. The same constants that govern stars determine the chemistry of our blood. The universe does not stand apart from us, it moves through us, and we through it. Every question we ask about the cosmos, what lies beyond, why are we here, is really a question about ourselves. We are the only creatures, as far as we know, who can look at the night sky and feel both small and infinite in the same breath. We build telescopes to peer across billions of light years, but what we're really searching for is a reflection proof that our brief flicker of awareness is part of something vast and meaningful. And that reflection is there, written in starlight and silence. The cosmos is not indifferent, it is participatory. It gave rise to observers who could one day turn back and contemplate it. We are the universe becoming self-aware. When we reach the edge of the observable universe, we reach the edge of our comprehension, a horizon not of distance, but of perspective. Beyond it, physics fades into speculation. Yet even here, there's wonder in the limits. The fact that we can know there's more beyond what we can see means our curiosity extends further than light itself. Perhaps that's the greatest revelation of all, that in a cosmos defined by darkness and silence, consciousness itself is the rarest form of illumination. Against the backdrop of endless expansion, thought becomes an act of defiance, a spark of order in an ocean of entropy. The universe expands, dark energy accelerates, galaxies drift apart, but awareness bridges what space divides. Every act of observation, every moment of wonder, every heartbeat in awe of the infinite becomes a small victory against the void. It's how the universe remembers itself. Maybe we'll never see what lies beyond the cosmic horizon. Maybe the edges of space and time are forever veiled. But even so, or perhaps because of it, our search becomes sacred. The pursuit of what cannot be reached defines what it means to exist. So when we look up at the night sky, we aren't just seeing stars, we're seeing evidence that the universe works, that it endures, that it dreams through us. The same physics that shaped galaxies shaped the neurons firing as you wonder about them. The same expansion that stretches space-time also stretches the boundaries of human thought. Perhaps that's the real purpose of the unseen universe, not to be discovered, but to remind us that the unknown still matters. Because without mystery, there would be no drive to learn. Without darkness, no need for light. We may never touch what lies beyond the observable universe, but we are forever touched by it. The light that reaches us ancient, distant, dying, carries the memory of beginnings we'll never witness. And yet we see it, we name it, and we understand enough to whisper back. Maybe that's the point. Not to conquer infinity, but to stand within it aware, fragile, and unafraid. Because even if the universe is endless, our curiosity is too.